All right, hello, welcome to this lesson then on similar shapes. It's lesson 2 now on areas of similar shapes. It's just a quick recap. Remember that two shapes in maths are similar if one is an exact enlargement of the other. See, these two shapes are similar because, see these two sides here? 70 is 10 times bigger than 7, and 50 is 10 times bigger than 5. So this shape here, we call it shape A, has been enlarged by a scale factor of 10 to make shape B. That means they're similar shapes. So example now, we're looking at areas today. So pause the video, write this example down, and then come back to me when you're ready for the answer. Okay. All right, welcome back. So I'll try and get it on this slide. If I can't, I'll go on to the next slide. So A and B are similar, no probs. Find the length scale factor of the similarity. Right, so I'm looking at it now for some matching sides, and I see that this 2 and this 4 are matching sides. So I'm trying to think in it, what's my scale factor? Well, it's obviously 2 in it, okay, because 2 times 2 is 4. All right, so the scale factor here, the length scale factor, all right, is times it by 2. Find the value of x. Well, I mean, common sense now, and if the top side's 5, that's also 5. And we can see here, can we? All right, this shape's got to be twice as big. So 5 times 2 is going to be 10 centimeters. Right, now the area of both shapes, I'll do it here. Let's do the area of A first of all. Remember, a rectangle's area is length times width. So it's 5 centimeters times 2 centimeters, which is 10 cm squares. The area of B is, well, sorry, I forgot. Remember, x was 10. All right, so I have to do 10 centimeters times 4 centimeters, and that's 40 cm squares. Okay, easy peasy. Now, part D, find the area scale factor of the similarity. So if you look at the two areas, see, here's my two areas. What is the scale factor here? All right, remember, how many times bigger than 10 is 40? Well, I reckon 10 times 4 is 40. All right, so the area scale factor, I'll call it area S dot F. The scale factor is times by 4. And what you notice is, unlike with the lengths and perimeters, see, these two, the length scale factor and the area scale factor, see, times by 2, times by 4, they're not the same this time. All right, so bear that in mind for today, but there's a connection between these two. We'll try and spot it as the lesson goes on. Okay, example 2. If you want to pause the video, all right, put the example down and then come back to me when you're ready. Okay, nice one. Right, so this one, I probably have to go on to the next slide for this one, I think. All right, we'll see how I go. So the similar shapes, find the length scale factor of the similarity. Well, I see that these two sides here are the same. And I think that 8 times 3 is 24. Okay, if you couldn't do it in your head, remember, you can always just do 24 divided by 8. And that will give you the factor as well, times by 3, okay? Work out the value of x. Well, these two correspond, don't they? All right, so 2.5 times 3 I've got to do now. All right, so 2.5 times 3. And whichever way you do this, you're going to get 7.5. Sorry, meters. So x is 7.5 meters. So let me put that on the picture. All right. Now find the area of both shapes. All right, I'll go on to the next slide for this. So the area of C, first of all. Area of C. Remember, for a triangle, the area is base times the height divided by 2. Okay, so I have to do, sorry guys, I have to do 8 times 2.5. So 8 times 2.5 divided by 2. Now 8 times 2.5 is 20, and half of 20 is 10 cm squares. And the area of F, again, remember, is base times height over 2. If you look at F, is 24 long, 7.5 high, I believe. Let me just check. It is. And I'm dividing by 2. And I just realized that. Is there a small area? Yeah. Oh, look. No. Yeah, it looks like this should say centimeters here. And that should say centimeters there. Sorry, guys. My bad. I'm sure you spotted that. All right. 24 times 7.5. Oh, I think that's 180. Yep. Divided by 2 is 90 cm squared. Okay. So there's my two areas here. And then question D is asking for the area scale factor. Okay, so if you look at your two areas, which are here, what is the scale factor there? Well, can we see? I'm just thinking, how many times bigger is 90 than 10? Well, it's times by 9 in it, I think. If you don't believe me, you can check. 90 over 10 is 9, okay? So the area scale factor is times by 9. And again, you note this, right? The length scale factor was times 3. The area scale factor was times 9. All right, so they're not quite the same, but there's a definite connection. So for the main task now, all right, it goes over 2 slides. So here's the first slide. So pause the video and have a go at these first 2 questions. All right. Once you've done those, go on to push play again, and here are the next 2 questions. Okay. When you get to question 3, all right, you might have to look up the formula for the area of a trapezium. Okay, so if I go back now to question 1, all right, I'll leave it there for you. When you've done question 1 and 2, go on to the next couple of slides, all right, and keep going. In fact, what I'll do, I'll write the trapezium formula on the next slide for you as well. So do these slides first, all right, then go on to the next slides. Pause it here. Okay, you use the next 2 questions on the main task, so pause this video. But before you pause it, remember, a trapezium's area is given by 1/2 brackets A add B times H, okay, where A and B are the parallel sides and H is the height. So remember, the area is actually 1/2 times A add B times H, okay? Do the brackets first and take it from there. So pause here, guys, and have a go at these 2 questions. And when you're done then, the next 2 slides you can view will be the answers to the entire main task. Okay, welcome back. Here's the answers for the first 2 questions. So pause the video and mark them. And then if you push play again, here are the answers to the last 2 questions. All right. So now let's go on to a checking question then. Okay. Right, so pause the video, put ahead and checking question, write the question down, then come back when you're ready to go over the answer. Okay, guys. Shapes E and F are similar. The area of shape B is 15 cm squares. Let me put that in here, 15 cm squares. And the area of shape F is 1,500 cm squares. Find the values of X, Y, and Z. Okay, I can't find anything. I can't find X, Y, or Z at the moment, can I? Because I haven't got any matching sides at all. But what you need to notice now from the main task and the examples, can we see, look, I'm looking for a connection here. The connection is between the length scale factor here is 2, and the area factor here is 4. And I reckon that 2 squared is 4. Here, look, I got 3 and 9. 3 squared is 9. Okay. And this one, I got 4 here and 16 here. 4 squared is 16. And even here, I've got 10 here and 100 here. And 10 squared is 100. All right, so the trick to notice here, all right, I'll write it down here. The area scale factor of similar shapes is the length scale factor squared. Okay, so if you look at these 2 areas now, okay, all right, I've got the area of E is 15 cm squares, and the area of F is 1,500 cm squares. And can we see? I can work out the area scale factor here. All right, if you can't do it in your head, just divide the two. But I think it's obvious that the area scale factor here is actually 100. You see, this is actually 100 times bigger. Right? So now look, I've got here 100 is basically the length scale factor squared. And I need this length scale factor to work out these missing lengths. So I'm thinking now, like, what number squared is 100? Well, I think it's 10, isn't it? Yeah, it is. If you don't believe me, okay, then perhaps you could take the root of 100 to work backwards, and you would get 10. So the length scale factor is 10. And now it's easy, because to find y, I know that these lengths are 10 times bigger. So 5 times 10 is 50 centimeters. All right. And if I want to find x, well, can we see, look, I know the area is 15 cm squares. All right. So doesn't that mean that, where can I go up here somewhere? Sorry, a bit of a mess here, guys. 5 times something must be 15, look, because the area of a rectangle is length times width. So I think that the question mark must be equal to 3. X has to be 3 centimeters, because 5 times 3 is 15. And now I know x. I can work out z as well, can't I? Okay, because I know that z is 10 times bigger than 3, and 3 times 10 is 30. And with that, I am done. The important thing today, guys, is this statement here. So what separates the A-star students from everyone else? Learning these key formulas. The area scale factor is the length scale factor squared. So thanks for listening, guys. Stay safe, and we'll see you soon.